Hey viewers, welcome back to Ray of All Trades. I was contacted by a company who was watching my videos, and they asked me to review one of their lithium batteries for my RV. And I said, sure, absolutely. So they sent me the battery for free, and they asked me to give an honest opinion. They're not paying for my opinion, but they did give me the battery for free. But let's unbox this thing and see what we get. So the company was LiPULS. Came in a very well marked and sealed up box. Shipped in without any kind of problem. Actually came in really fast. I was very surprised. So my RV has 6 100 watt panels on top of it, and I bought the RV used, and the people had taken the inverter out of it. So they had also swapped out the lithium battery for a lead acid battery. Needless to say, the lead acid battery doesn't quite do what a lithium battery is supposed to be able to do. They say, and I'm sure I'll get this wrong, but they say lead acid batteries can only discharge to 80% of their value, whereas a lithium battery can discharge, lead acid batteries can only discharge 20% of their value down to 80% charge, whereas a lithium battery can deliver, I don't know if it's 100% or really close to 100%, but they can actually deliver that charge for a longer period of time. You also have, I think it's 4,000 full cycles, whereas a lead acid battery, like on my boat and on the camper, don't seem to have that same length of charge. There's lots of literature on these things out there, but I wanted to try this to see if it would work. Plenty of styrofoam. Okay, so nominal voltage is 12.8 volts. I think it's lithium, so it might be a little bit higher than that. But nominal capacity, 200 amp hours, meaning it could run 200 amps for 1 hour, is how they rate batteries like that. Capacity at 40 amps would be 300 minutes in length of time. The energy that it's capable of producing is 2,560 watt hours. Resistance across the terminals, I'm assuming, is less than 10 mega ohms. The self-discharge capacity, I'm guessing if it had no load at all, would be less than 3% per month. And cells being prismatic, I don't know what that means. So recommended charge current 40 amps, which is really good. My RV has a lithium setting on the converter, and I want to say it says 50 amps. Maximum charge current 200 amps, so obviously it can take it. Recommended charge voltage would be 14.6 volts. And then the BMS charge cutoff voltage is less than 14.6 volts, 3.65 volts per cell. Maximum batteries in connection, 4P4S. So 4 parallel and 4 series is what that stands for. Parallel meaning that you would get the same voltage and increase your current, and series would meaning that you would keep your current the same and you would increase your voltage. So discharge performance, maximum continuous discharge current of 200 amps. BMS discharge cutoff current is 450 amps, plus or minus 20 amps. It says 31 ms. I'm assuming that means 31 milliseconds. And then BMS discharge cutoff voltage is whenever it gets 10 volts. I'm believing it's saying that it can take it down to 10 volts and then it'll shut off. And then it has a short circuit protection of 200 to 600 microseconds, meaning that if it gets a short, so way less than a second, it'll actually shut itself off. And then the terminals are M8 metric bolts. And then the weight of this whole battery is 52.9 pounds, which is awesome because I now have one battery that has a much longer lifespan than the one lead acid battery that I have. The one lead acid battery I have is more than 52 pounds. I think it's closer to 75 pounds for a Group 31 battery. I can check it and verify, but I can tell you this is definitely lighter than the one battery I have in there right now. It does take up the space of 2 of my batteries. Group 31, it would probably be about that big. Group 27s are about that big. So probably the same size as 2 Group 27 lead acids, and just slightly larger than a Group 31 battery. But that's pretty cool. If all of this is true, which I've seen other videos that show that all of that is true, that's pretty awesome. Let's see. Just gonna try to lift this right out of here. Easy enough. A little heavy, but easy enough. The rest of the box is just a lot of styrofoam. They've got protectors over the top of the bolts. I heard somebody else point out that they would have preferred to see the bolts off of it versus being, mounted to it. I mean, I guess you could do that, but I mean, if I went into a store, I'm going to have this exact same setup. When I order AGM batteries online, a lot of times those bolts are missing. In shipping, I know in shipping, a lot of times the protectors, it'll just be the lead stud sticking up and then the bolts are hanging off to the side. But realistically, what difference does it make if this bolt is here? Because normally there would be a lead lug sticking up. I'm sure there's a valid reason for it. I don't see it as that big of a deal. This thing is so cool. All right. They say it's 50 pounds. It feels a little bit less than that, but I'm positive that they are right on the money. So basically what I'm saying is it's lighter than I expected it to be, especially for its size. Let's get a couple of preliminaries on this thing. So DC volts. So yeah, it's sitting voltage right now is 13.178 volts on that meter. Since I have 2 meters out here, we're going to go ahead and just try the other one. .5 on this meter. Not crazy that the Flukes, these are good meters, not crazy. I guess this one needs to go in for calibration, I believe. It's got a lot of abuse. Let's go ahead and hook this thing up to the inverter. Now in all fairness, I literally just bought the inverter and haven't even tried it on anything yet. Just finished plugging it in. So it's directly out of the box and plugged in. 13mm wrench. I'm going to hook up the positive first, and then I'm going to hook up the negative. It doesn't matter right here, but imagine that you're in a metal enclosure, right? And you are hooking up the negative first, and then you're trying to tighten up the positive, and you've got a completed circuit. Well, while you're using a wrench, a metal wrench, and you're tightening up this as the secondary feed, if you short to the chassis of the vehicle, you could actually short out. Now, if you hook up the positive first, you could hit metal all day long because you don't have a connection from here to the metal frame to complete the circuit. So that's why I hook up the positive first. There you go. Could use that later on. Alright, now let's hook up the negative. The only thing here I should have to be cautious of is from when I'm tightening this, is touching here. Alright, let's turn on this inverter. Okay, we're going to set this up for voltage so we can continue reading DC voltage at the battery supply. So 13.054 right now. DC amp inductive probe. Let's zero that. The inverter in the off position. I'm pulling 0 amps, 13.069 volts. Let me just turn on the 3000 watt inverter. So it's powered on. Looks like I'm pulling about 0.5, 0.6 amps, so that'd be about 600 milliamps is what that equates to. Let's turn power on to this thing. This claims it's sitting at 12.8 volts. Again, I believe the fluke meter is over the little remote power panel. Yeah, the panel itself is reading almost a full battery and 12.8 volts. And then that part of the panel, 122 volts, 12.9 volts input, and it's producing 60 hertz. And then we're going to hook up a 1000 watt heater to that inverter, and let's see what occurs. I'm going to get you guys into the meters, but all I'm going to do is turn on power to that heater. Let's see what occurs. Okay, with the inverter on, I'm pulling 700, 800 milliamps, something like that, where I'm sitting at right now. Power at the battery is 13.0 volts. Inverter claims it's 12.7. Again, I trust the fluke meters more. All I have is that 1000 watt heater. Let's go ahead and turn it all the way on. Looks like I am pulling 85 DC amps out of the battery right now. And the voltage is dropping. So the battery says it can do 200 amps. So I'm only at half of its capacity, or less than half of its capacity. And knowing that the battery was not fully charged, it claims its nominal voltage is 12.8, but it's supposed to charge with 14.6 volt. It will shut itself off once it reaches below 10 volts. So I've heard that when you charge these batteries up and you've got a resting voltage, that they will be at like 13.6. So literally, I just took it out of the box and it had enough charge to run a heater that is cooking my leg right now. 84 amps, and that battery is holding pretty doggone steady at 12.4 volts. So half of its capacity is coming out of this battery right now. It's pretty impressive. That's a pretty powerful heater. This thing has been going an incredibly long time. While I was cleaning up the box, I noticed that they also sent me a spare set of bolts. Nice carry handles. Battery's not getting warm. I wouldn't anticipate it to, but the battery's not getting warm. It's not going to off gas like the lead acid battery that you constantly have to have connected to the outside so that the hydrogen gases from charging a battery would produce. All in all, I'm really impressed. Alright, so I turned the heater off. My resting voltage came back to 12.9. My current draw is sitting right at about 0.6, so 600 milliamps. That's because the inverter is still powered up, even though it's not supplying anything. So let's go ahead and turn off the inverter. Okay, that's the remote power of the inverter. So 0.7, so still 700 milliamps. Let me kill the power to it. So shut off the power to it, and I dropped to 0.1, so 100 milliamps just by having the inverter plugged up to it. And my resting voltage came back to 13. Pretty impressive. Again, they gave me the battery for free to check out, but had they not given it to me for free, this is definitely one of them I would have considered purchasing, because it is a good battery, and it's going to fit in very nicely with my little 600 watt setup that I have on my camper. So in the market for a lithium battery for your camper, for your solar, or for just having a lithium battery because you want to reduce weight, the total weight, and you want to not have to worry about those hydrogen gases coming up from a lead acid battery, consider one of these batteries. It would take quite a bit to short these out, especially if you put the caps back over the top of it. And it does have an internal short protection if something does fall on it, which a lead acid battery does not. So far, I'm kind of happy. Nice job, LiPULS. I'll link these in the description if you guys are interested. Again, They gave me the battery for free, but they did not pay for an opinion. They said, give us an honest opinion on what you think, and so I'm giving you my honest opinion. So hope you guys got something out of the video. Really appreciate you hanging out, and I'll catch you on the next one.